Okay, in this video I'm going to be talking about how we go through and find our x and y intercepts algebraically. So that means without the use of the graph. You don't actually need to see the graph in order to find what the intercepts are. So let's hop into some examples of this. Let's say that I have y is equal to 3x minus 1, and I want to find the x-intercepts as well as the y-intercepts. So recall that the x-intercepts are the point at which the graph crosses the x-axis. So we know that our y-coordinate is going to be equal to 0 because the y level that the x-axis lies on is y is equal to 0. And likewise for the y-intercepts, we know that the x-coordinate is going to be equal to 0 because the y-axis runs along the line x is equal to 0. So using this information, we can actually plug in 0 for their respective coordinates in the equation and then solve for the remaining variable to see what the coordinate of the x and y intercepts are. So let's plug in y is equal to 0 into our equation here, and we get 0 is equal to 3x minus 1, and then you just solve for x. So we add 1 to both sides, and we get 1 is equal to 3x, and then if you divide by 3, you end up with x is equal to 1/3. So what that tells us is that our x-intercept is the point 1/3, 0. Meaning this graph is going to cross the x-axis at the point 1/3, 0. So likewise for the y-intercept, what I'm going to do is I'm going to plug in 0 for x. So I will have y is equal to 3 times 0 minus 1. Well, 3 times 0 is just 0, so that goes away, and I get y is equal to negative 1. So my y-intercept is the point 0, negative 1. And this makes sense because we have an equation that's in slope-intercept form, and you can see how this b is the y-intercept. So whatever constant number you have, if it's in slope-intercept form, that is going to be the y-intercept, because if you plug in 0 for x, all you're going to be left with is y equals that number. Okay, let's go into another example. Let's say that I have y is equal to negative 5x plus 6. So I'm going to try the y-intercept first. So that means setting x equal to 0. And if I set x equal to 0, well, we recognize that this is in slope-intercept form. So I know that my y-intercept is going to be the point 0, 6. But I'll plug in x is equal to 0 just so you can see. So I have y is equal to negative 5 times 0 plus 6. Well, negative 5 times 0 is 0, so I'm just left with y is equal to 6. Therefore, my y-intercept is the point 0, 6, which makes sense because that 6 is the number that we have over here in slope-intercept form. That's what this means. This is where the y-intercept comes from. So if I go for the x-intercepts, I have to set y equal to 0. So I'll say that 0 is equal to negative 5x plus 6, and then I just solve for x. So I subtract 6 on both sides, and I'm left with negative 6 is equal to negative 5, x divided by negative 5, and you get x is equal to 6 over 5. Therefore, my x-intercept is the point 6 over 5, comma 0. Alright, now that you get the general gist of it, I'm going to go through a few more examples relatively quickly. So I have y is equal to 2 times x minus 4. And if I want to find the y-intercept of that, I would convert this first into slope-intercept forms by distributing. So I have y is equal to 2x minus 4, or minus 8, excuse me. Let me just edit that, minus 8. And then for the y-intercept, I set x equal to 0. And since this is in slope-intercept form, I know that my y-intercept is going to be 0, comma, that point. So I have 0, comma, negative 8 for my y-intercept. And for the next one, the x-intercepts, I just set y equal to 0. So I'll have 0 is equal to 2x minus 8. And then I'll solve for x. So that goes away, and I have 2x is equal to 8 divided by 2. And I have x is equal to 4. So this means that my x-intercept is the point 4, 0. Okay, let's do another one. Let's say that I have y is equal to 4 times 7x plus 1. And for the y-intercept, first thing I'm going to do is distribute so that I have 28x. So I have 4x times 7x plus 1 is equal to y, which is equal to 28x squared. Whoops, hang on. Okay, so if I wanted to find the y-intercept, meaning x is equal to 0, all I'd have to do is distribute this out. So I have y is equal to 28x plus 4. And if x is equal to 0, then this goes away, and I'm just left with y is equal to 4. So I know that my y-intercept is equal to 0, 4. And as for the x-intercept, it's the same kind of thing, except I'm plugging in 0 for y. So I'll have 0 is equal to 4 times 7x plus 1. I can divide the 4 out since I have a 0. 0 divided by 4 is still 0. So I have 0 is equal to 7x plus 1. And then I just solve for x. I subtract 1 from both sides. So I get 7x is equal to negative 1. And then when I divide by 7, I get x is equal to negative 1 over 7. So my x-intercept is going to be the point negative 1 over 7, comma 0. Okay, got a couple more for you. Let's say that y is equal to negative 1/2 x plus 2 over 3. So even though we have fractions, it's the same sort of procedure. What I'm going to do, y-intercept, I recognize that this is in slope-intercept form. I have negative 1/2 as my slope, and 2/3 is going to be my y-intercept. So I can just directly say that my y-intercept is the point 0, 2 over 3. Just because I can recognize that it's in the slope-intercept form, I can just jump straight to that for the y-intercept. But for the x-intercept, I set y equal to 0. So I have 0 is equal to negative 1/2 x plus 2 over 3. And then the process is the exact same. So I'm going to subtract 2/3 from both sides. So I get negative 1/2 x is equal to negative 2/3. And then what I'm going to do is divide both sides by negative 1/2. So I end up, negatives cancel, with x is equal to 4 over 3. So my x-intercept is going to be the point 4 over 3, comma 0. Process is the exact same thing whether you have fractions or not for linear equations. Okay, this will be the last one that I go through. So this is going to be y is equal to 3 over 4x minus 1 over 4. So again, I got slope-intercept form, so I can directly say that the y-intercept is the point 0, negative 1 over 4. This is why that slope-intercept form is so convenient for finding the y-intercept, because it's just whatever constant number that you have at the end of the x term. But for x-intercepts, I set y equal to 0, so I have 0 is equal to 3 over 4x minus 1/4. So I'm just going to be solving this linear equation. So I'm going to add 1/4 on both sides. So I get 3/4 x is equal to 1/4. And I notice I have a common denominator here of the 4. So I can actually multiply both sides by 4 to get rid of it. But you can also just divide both sides by 3 over 4 and you get the same thing. I get x is equal to 4 over 12, which is 1/3. So my x-intercept is going to be the point 1 over 3, comma 0. So I hope this video was helpful about how we use the rules of algebra and basically the definitions of the intercepts in order to find them algebraically. So you don't need the picture of the graph to figure out what the intercepts are. So x-intercepts cross through the x-axis, y-intercepts cross through the y-axis. So with that being said, the x-intercepts are always going to have a y-coordinate of 0. They set the equation equal to 0. And the y-intercepts are always going to be what the values are when x is equal to 0. So I hope this video was helpful and you stay tuned for the next one.